This is the Panasonic Aquarea M series. The Panasonic Aquarea M series is an R290 unit. So instead of it being an R32 unit, it can reach higher temperatures. It's natural refrigerant, so propane. It can reach higher temperatures using less energy. This is indoors in our premises. We installed it yesterday, had a little change around. We've connected it to the small radiator circuit that we have for demonstration purposes, and we've also connected it to the 300 litre Aquarea tank. We've also got the control module which comes with the kit. The control module, it would normally be lower on the wall, but because we're running out of space on this wall and for you to be able to still see it, we needed it a little bit higher just for demonstration purposes. So the M series, R290 driven, it's a TCAP unit, total capacity TCAP. So that means its data badge capacity, its kilowatt output capacity. It will deliver that even when it's as cold outside as -20. However, further added to this, it will still give you reliable heat even when it's as cold outside as -28 degrees C. Fabulous, absolutely amazing technology. It gets even better because the R290 unit can deliver temperatures for flow or water outlet temperatures of up to 75 degrees. Even when it's -15 outside, it can still deliver up to 75 degrees. So that would mean to do your hot water cycle, it can do your sterilisation, your weekly pasteurisation of your unvented hot water cylinder. It can do its weekly cycle without using an immersion heater or a backup heater. So it can do it all itself using less energy, therefore giving you more efficiency. So we're saving on electricity, essentially, because the R290 can do it, using less energy. So, M series, R290 TCAP, starts from 9 kilowatts all the way through to 30 kilowatts. So with that, we've got 9, 12, 16 kilowatt single phase, 3-phase options. Then we've got the Big M. Big M's are 20 kilowatt, 25 and 30 kilowatt units. But even more so, M series is totally scalable. So when we say totally scalable, we can cascade 10 units or up to 10 units in sequence. So let's just say a commercial building owner who's looking to comply with current sort of government guidelines for efficiency in buildings. Maybe you're thinking, I need to get my fossil fuel out and get a renewable in, but I need, let's say 298 kilowatts of efficient heat and hot water solution. We can put 10 30 kilowatt units in sequence. So, we tick every box for efficiency and scalability. So, at the moment, I've got this connected to a small radiator circuit, and what I've done, I've just set it to weather compensation at the moment, but I'm going to change it to direct temperature because a little demonstration I want to do. I want to turn the temperature of the radiators up, just to show that we can get that high temperature into those radiators for clients who are maybe just wanting to see a little bit more, information, or obtain a little bit more information on can it really do those temperatures in my radiators. So their existing boiler may put 60, 65 degrees into those single power, single convectors, and house may be lovely and warm after 20 minutes. Great. What that client may want to know now is, but if I change to a heat pump, can it do the same? If I need it in the winter, in the worst of winter, if I really want to turn up that, can it do it? So I just want to do a little test. So I'm going to put the video on pause. I'm going to change it to the direct flow, and we're going to turn the temperature up. And we'll just have a little bit of fun, because it gives you the opportunity, by us doing this online with you, it gives you the opportunity to have a little bit of fun, listen to me witter on, and then, you get to see what it really can do. So now you can make an informed choice whether you want to have a M series from your home, or maybe you just want to see a little bit more information. So maybe we have to do another video for you. So who knows? But yeah, it's just about having a little bit of fun and then sharing, this information, because look, if you've seen some of our previous videos, we've got the K series with the all-in-one, J series with now it's with a third-party smaller 150 litre tank. We've got the M series with the 300 litre, and we've got commercial air-to-air solutions and residential air-to-air solutions as well, which you've probably seen by now. If not, give them a watch, because they're quite informative to an extent. But it's all about sharing all this information with you, so you can make some choices as to whether you want to go green and, future-proof your home and lower your carbon footprint and things like this, and basically just have better efficiency for your heating and hot water solution. So, the information, it helps us improve our product knowledge by having these units in our business premises, but it also helps us demonstrate how they perform to you. So, you can make some choices. So I'm going to pause this video. I'm going to crank the temperature up in the controller and change it to direct flow, and let's have a bit of fun. See you in a few. In this video, we've got the M series running the radiator circuit now, and what I wanted to do on test one was to set a direct flow temperature of 65 degrees. So you can see that I've got my two Testo smart probes connected. One's on the flow and one's on the return. And if I just put the screen of my tablet in front there, we can now see, I want you to have a look at the timestamp in the top left as well. So, just make a note of that timestamp, and then you can see the flow temperature going into my radiators now. So we've got almost 60 degrees flowing into it. So remember, I said I wanted 65, so we're running that. So once I see that happen, I will then pause the system, and then I'm going to turn this up, a bit higher, and let's see if we can get, to a higher temperature still. So, the aim of these tests is to show you basically what the unit can do. This isn't about sales, or trying to, sort of sell heat pumps. The heat pumps will sell themselves to those that want them. It's as simple as that. But for those that want them, we want to be able to show as much performance information as we can online, so you can witness these tests with your own eyes and make your own decision. So it's not always a real world scenario, because the heat pump's inside the building, but we try and get as close as real world as possible, and because the R290 unit is capable of delivering a higher flow temperature of up to 75 degrees, even when it's as cold as -15 outside, a test like this gives an indication to a viewer, well, that's quite impressive what it can do. You've seen it go into the radiators, with the Testo clamps, and at the moment on the Panasonic Aquarea controller, I've got it on system information. So on system information at the moment, I've got 26 litres of flow. I've still got 66 degrees in my tank from the earlier test we did on hot water. And I've got an outlet of 64 degrees and a 5-degree delta T with an inlet of 58. So the heat pump is maintaining its 5-degree delta T even at a higher temperature. This, quite important really, because, hang on a minute, we've got a butterfly in. Can't beat nature, can you? So, with the demonstration that we're doing now, what we're showing is the R290 can deliver that higher temperature using less energy, doing it much more efficiently. So for clients who may be thinking, oh, I'd love to have one, but you know, will it do the same as what my boiler can do now with my existing radiators? Well, the answer is already yes, because your boiler would typically put a flow temperature in of, as I said in the earlier video, of, sorry, I'm just watching the butterfly flying around. Your boiler is probably going to put in a flow temperature of what, 60, 65 degrees? Typically, most boilers would put, if you crank them up, they'll put about 60, 65 degrees into your radiators. So within 20 minutes of you turning your thermostat on, usually your rooms are lovely and warm, the radiators are nice and toasty. So you may be thinking, I don't know with a heat pump because, will it do the same? Well, this has already surpassed 60 degrees, and I've not actually set the set point to a higher 70 plus degrees. I've only set it to 65, and we're on our way to that. And in fact, actually, these are Bluetooth paired. These temperature clamps, they are Bluetooth paired. But you can see, if you noted the timestamp when I said just a few moments ago, if you see where we're at already, it doesn't take long to get up to the temperature. So it's far simpler, actually. The weirdest thing, I'm kind of stood here, I've got the cold from the fan blowing, and then as I stand here, I've got the heat from the radiators. So, they are, where a person would say, oh, my radiators are lovely and hot, with my boiler, that already is on par or better than my radiators are lovely and warm with my boiler. So that's just a simple test. I've only got the 4 double fan, double convector units just hooked up there, 22mm and 15mm pipework, and this is direct flow. Now, what I've done, has been a little bit crafty. I've turned, because I've said I'm using a Panasonic controller as the actual indoor room thermostat, I've turned it up to 30 in here. This is just a shy of 1,000 square feet building. So this has got some work to do. But my point being, I'm asking for a temperature from my, from my heat pump. And, I said, please give me 65 degrees flow temperature into my radiators. And, it's such a, you've got to be mindful, like I said, about real world scenarios. This is just 4 radiators closely, sort of hooked up together. So that flow and return temperature on the radiator circuit is going to be quite close, isn't it? But on the controller, what we're looking at is the temperature coming from the flow off the heat pump and the return going back into the heat pump. And we've still got that 5 degree delta T. So if I just have a look now, I've got an outlet temperature of 66 and an inlet now of 62. So, it's a little bit tighter, but you're still trying to maintain that. Now, if, a person were to put their hand on these radiators, they would express that they are really hot. So, this little test, albeit I've only targeted 65 degrees, I've reached it, I've proved it, I've done it in a very, very short time frame. For those of you who made note of the time in the top left corner of my iPad. So we're not even asking for 75. We know that we've already met or matched most boilers. Most boilers turned up to full 60, 65 degrees into your radiators. Just in a short exercise, I've demonstrated our M-Series TCAP R290 unit can match or surpass it